Hey Chem students, today we are going to practice finding our empirical and molecular formula when we are given our percent composition and molar mass of our compound. So the example I'm going to use is 85.6% carbon and 14.4% of hydrogen, and the total molar mass is 42.1 grams per mole. Okay, there's two ways to do this. The first way I'm going to do is the way that Abeka teaches it, which to be honest, I think is a more difficult way, but you can decide for yourself which way is easier for you. Okay, so doing it Abeka's way, the first thing we are going to do is I'm going to assume that we have 100 grams total for our molecular mass. So if I have 100 grams total, that means that because carbon is 85.6%, I'm going to multiply it by 100, because remember, percentage means that this is over 100, so that cancels out and I'm left with 85.6 grams. And then hydrogen, multiply by 100, you'd get 14.4 grams. Then what you're going to do is you're going to divide those numbers by that element's mass. So carbon is 12.01 grams, and hydrogen is 1.008 grams. So when you divide those, carbon you will get 7.13, and hydrogen you will get 14.29. Now I need to figure out the quantity in my molecule. So in order to do that, I'm going to find the lesser amount out of all your elements. In this example, we only have 2. So I'm going to divide by 7.13 to everything because that's my lesser amount. So of course for this one you get 1, and then you want to round to the closest whole number, and you should be pretty close to it being a whole number anyways, so this one will be 2. So we've got 1 carbon and 2 hydrogens in our empirical formula. Now I need to find our molecular formula. So first I need to find the mass of my empirical formula. So we know that carbon is 12.01 grams and 1 hydrogen is 1.008 grams, but we have 2 here. So 2 of those then would be 2.016 grams. So the total is 14.026. Now I need to divide my total molecular mass by the empirical formula mass. So 42.1 divided by 14.026, if you put that into your calculator, you'll get 3. So what I need to do is I need to multiply my entire molecular formula by 3. So that means that for carbon, because there's an understood 1 for the subscript, now 1 times 3 is 3. Hydrogen, you have 2, so 2 times 3 is 6. So you've got your empirical formula and your molecular formula. Okay, now let's go ahead and do it my way. Okay. So what I'm going to do is I'm actually going to change this into a decimal. So 85.6 divided by 100, because that's how you figure out the decimal for percentage. And then I'm going to multiply it by the total molecular mass, 42.1 grams per mole. And then finish it off by multiplying by the mass of carbon. But remember, dimensional analysis, I need these units to cancel. So I'm going to put my grams on the bottom. Per mole goes on top. So those cancel out. Then put it into your calculator. So 85.6 divided by 100 times 42.1 divided by 12.01. Remember, everything on the top, or numerator, gets multiplied. Everything on the bottom, or denominator, gets divided. So what you'll end up with is 3. Then I'm going to do the same thing for hydrogen. So take that percentage, put it over 100, so it will turn into a decimal. Multiply it by your total molecular mass, that is information you were given in the question. And then multiply it by the mass of hydrogen, which is 1.008 grams per mole. And so these cancel out. Do the math and you will get 6. So you've got 3 carbon, 6 hydrogen, that's your molecular formula. All you have to do, simplify these subscripts as much as you can. 3 can be divided by 3, 6 can be divided by 3. So you end up with 1 carbon and 2 hydrogen. So there you go. You got your molecular formula and your empirical formula. Pick whichever way is easiest for you, and good luck.